Hello again and welcome to Perth South. In previous videos I looked at the prototype Perth station and why I wanted to model it. This was followed by an explanation of the layout plan and baseboard and track construction. This time I'll explain the operation and control of the layout. On returning to the hobby after many years, I've been astonished at the changes and improvements that have occurred, and I was keen to adopt and use as many of these new ideas as I could. In particular, DCC, sound-equipped locos, and tablet computer screen control interface. I wanted to run a complex and busy schedule of trains, recreating the movement and timetable at Perth from the early 1960s, but wanted to be able to do it either with help from friends or single-handed. As an ex-railwayman, I was keen to have a working signalling system interlocked with route setting of points. I was concerned about operator error, with many opportunities for collisions, especially in the hidden sidings where derailments are difficult to deal with. I became interested in the examples of computer control available, and after looking at the options available, decided to use the Railroad & Co. train controller software. This isn't the cheapest option, but appeared to me to be the best and easiest to use. The silver version gives me all I need at the moment, including full train automation, control of routes and signals, and ability to run a timetable. I have to give a shout out and a note of thanks to Dave Townend and the McKinley Railway crew, as it was their early videos from a few years ago that clearly laid out the architecture of their Digitrax equipment and its interface with train controller. I've unashamedly copied what they did, updating a few things, and guess what? It all seems to work. Thanks also to Rudy for his series on train controller, which takes you pretty well step by step through setting up train controller. Now, for anyone interested in computer control, there are a number of key things to bear in mind when setting up a computer-operated model railway. These comments derive from my experience with train controller, but I'm sure will apply to any of the available computer control systems. 1. Think about what you want from the layout and how you want to operate it. Do you want the computer to control signals as well as points? Do you want it to be able to shunt stock or run trains round a main line while you do the shunting manually? These decisions will help you finalise your track plan and will determine what level of computer software you require. On this layout, I want lots of trains running automatically to a timetable and being stored and turned automatically in the hidden storage area, while I manually shunt and prepare locos and trains in the station area ready for their next duty. I have train controller silver at the moment, as this includes automatic train control and control of signals, but I don't at present need all of the advanced features of TC Gold, although I am looking at some of the more detailed schedule controls in Train Controller Gold and may step up to this at some stage in the future. 2. Think about the train movements you want to make and be clear about which lines are bidirectional and unidirectional. It's very easy to create a situation where trains can become deadlocked, particularly with single lines. Try out your design using the simulation feature in Train Controller. It will show weaknesses in your design and allow you to make changes before you actually lay track. I made a few changes to my design after doing this. 3. Design your blocks to be long enough to comfortably take your longest planned train, or you risk having trains hanging out the back end of a block with a risk of collision from following trains. 4. Note there's a difference between the use of blocks and train detection feedback sensors. The standard arrangement in Train Controller is to have 2 or 3 sensors per block. In a unidirectional track, the large part of the block would have one sensor triggered when the train enters, and a second one for a short section at the end of the block which is the actual stop section. Once your loco reaches this point, TC knows your whole train is in the block and it can release the preceding route and block for another train. You can just use one feedback sensor per block, but you need to speed profile your locos very accurately, as the only way the computer knows when to stop a train is through calculating the time it takes to slow down and stop after it triggers the sensor at the start of the block. I've decided to go belt and braces and have included extra sensors and also included them in the routes between the blocks. One of the great things of this program is that you can have various levels of computer intervention. You can run a train manually in amongst computer-controlled trains, but you must obey the signals generated by Train Controller. Train Controller doesn't automatically accommodate UK signalling practice, but by using accessory signals controlled by triggers and conditions, you can replicate UK practice. I plan to do a future video which will explain in more detail my approach to signalling control using the logic of Train Controller and Digitrax hardware. So this is my Train Controller switchboard. This is the station and junction area. Over here is the loco depot, and these are the low-level hidden sidings. Blocks are shown diagrammatically by these rectangles. In reality, the blocks include almost all the plain line between sets of points. The sections of track between blocks, including all the sets of points, are known as routes, and Train Controller will automatically calculate routes for all connected blocks. In my switchboard, I've incorporated a number of different buttons and indicators. In each block, I've included a blue on-off button which, when activated, prevents the computer, the virtual dispatcher, from using the block for automatic train movements. This means I can perform manual shunting moves without interruption from the computer. At either end of each block are route setting buttons. To set up a route manually between blocks, I press the button at the exit end of one block and then press and hold the button on the next block or group of sidings. As well as setting up the route, the signal is cleared to the appropriate aspect. Signal main aspects are shown here in searchlight format, although the actual signals in the layout will be 3-aspect signals. Shunt signals on the diagram use one of the available continental style indicators, but the actual shunt signals in the layout again will be the regular British ground position light signals. Note that there are no blocks in the carriage sidings or in the loco depot, as I intend for these to be shunted manually. There are, however, route setting buttons for each of these groups of sidings, and the correct shunt signal is shown when these routes in and out of sidings are activated. On the hardware side, I'm using generally Digitrax equipment with 2 power districts, that is a separate booster for each level. Each booster feeds through a PM42 module to allow separate powered sub-districts and also manage the polarity changeover on reversing loops. Track power then feeds through a Digitrax BDL168 track occupancy sensor which detects current draw in a track section. Each one of these units can monitor 16 track sections. Points and signals are controlled by Digitrax SE8C units, each of which controls 8 slow motion point motors and amazingly up to 32 signal heads. I also use Signatrack DAC20 units for points only, again each one controlling 8 turnouts. Power to these units is separate from the DCC power, and commands are sent to them through the Digitrax Loconet cable. Thus there's no need for a DCC connection to these units, and thus no degradation of the power available for trains. I have 11 of these electronic boards with different combinations of electronic equipment situated round the layout. Everything in the layout has been designed for reliability, which is very important when using computer control. Thus all the turnouts are live frog and wired such that point blades and stock rails are electrically linked, with the crossing or frog controlled from the point motor in the switchboard. Tortoise slow motion machines have been used with an insulation piece between the point motor and baseboard, again to reduce noise. One important thing I want to mention is regarding the removal of the tie bar spring on modern Pico points when using them with slow motion point machines. This spring, in addition to creating the positive snap action from side to side, also acts in the longitudinal direction, pushing the blades towards the frog. Without the pressure of the spring, the blades can slip forward away from the frog, and the tip of the blade fails to close properly because it's no longer sitting in the notch in the stock rail. It's thus important when fitting slow motion point machines to have the actuator spring wire with a positive bend towards the frog position to recreate the effect of the original spring. Anyway, that's all for now. In the next video, I'll look at the reverse loops, the electrics that allow them to work, and test them out with a few trains. Thanks for watching, and hope to see you again soon.